Hello guys, my name is Deka and today I'm going to talk about electromagnetic induction. Electromagnetic induction is a very tricky topic and even I have a hard time picking up, so please listen carefully. In dictionary language, electromagnetic induction is defined as the induction of an electromotive force by the motion of a conductor across a magnetic field or by a change in magnetic flux in a magnetic field. Now this sounds very confusing, so I'm going to explain an easier way to understand the topic better.
This represents a neutral atom, where there are equal amounts of protons and electrons. It is possible for an outside force to push the electron away from the atom, starting a chain reaction. In electromagnetic induction, the magnet works as the force. The magnet is known to have a north pole and a south pole, and it creates a magnetic field around it. When the magnetic field goes through an atom, it pushes the electron away, creating a chain reaction. In this very good representation of a wire, the electron can move freely around the wire. But when the magnet, the force, goes through an atom, goes through the wire, it pushes the electrons away in one direction, creating an electric current, which is the basic of electromagnetic induction. With styrofoam magnets and wires, I've created a very tiny generator that can produce electricity through electromagnetic induction. With this generator, I'll show you three different factors that affects the electric current that are produced. The first factor that I'm going to talk about is the number of magnets. The number of magnets highly relates to the size of the magnetic field created by the magnets. Let's see what we can get with just two magnets. As you can see, you can get about just a little bit above 0.1 volt. Let's add another two magnets into the generator. One more, and now we have a total of 6 magnets in the generator. Let's see how much we can get. Now we can get to up to 0.3 volts. The number of magnets has increased the size of the magnetic field. Therefore, it can move more electrons at once, which creates more electric current, which results in higher volt. The second factor that affects the amount of electricity produced is the speed of spinning the magnet. If I spin this magnet really slowly, you can see that I'm creating around 0.1 volt. And if I spin this magnet faster, you can see that I'm always almost producing 0.2 volt. This is because the magnetic field around the magnet goes through the wire much quicker, pushing and creating more electron chain reaction in the same amount of time, resulting in a higher voltage. Coming in at our third factor is the length of the wire. As you can see, the size of this generator is so much more smaller than the previous one. This generator only has 180 coils of wire, while this one has around 350 coils. Let us see how much voltage this generator can produce. It seems that this generator can only produce about a maximum of 0.015. We can see that this is significantly lower than the generator that has 350 coils of wire. The length of wire means that there are more electrons, and if there are more electrons to move, there will always be more electricity produced.
Thank you guys for watching.